Welcome to this video on Kubernetes architecture. In the last video, we deployed a simple containerized static website to Kubernetes. I'm sure you are now eager to understand what Kubernetes really is. This is probably the video that you all have been waiting for. I believe you have enough knowledge to understand the inner parts of what makes a Kubernetes cluster. We will split the architecture into multiple videos, and this first video gives a brief overview of the various components of Kubernetes. So let's begin. We refer to Kubernetes as a cluster since it contains multiple nodes. Each node can be an independent physical machine or a virtual instance. For example, in AWS, an M2 medium is one node and we would use multiple such instances to form a cluster. The cluster is divided into two major parts, the control plane and the worker nodes. kubectl or kubectl is a command line client used to communicate with Kubernetes. The control plane is also known as the master. A single master node is enough to run a cluster. However, for higher availability, more than one master node can also be installed. The first component in the control plane is called the API server. It exposes a RESTful API to manage Kubernetes objects such as pods, services, and ingress. We will understand what those components are later on, but for now, all that we need to know is that the API is a window into the Kubernetes cluster. Every action that we want to perform on the cluster goes via the API. In fact, the API is also the only way by which the various components of Kubernetes can talk to each other and can access the shared state. In the previous video, we used the command line kubectl client to deploy a static website. kubectl accomplishes the deployment by firing a series of requests to the API. The API definition is exposed on the master using Swagger at the /Swagger endpoint and OpenAPI at the /OpenAPI/v2 endpoint. The API server serves REST operations. It is accessible from outside the cluster, whereas the nodes and containers may not be accessible from outside the cluster. The next important component is the cluster state store. The state of the cluster is stored in a key value storage known as etcd. etcd stores the cluster state in a consistent and fault-tolerant way. Any change to configuration is persisted in etcd and then propagated to the other components. etcd functions as a distributed data store and uses the concept of leader election. etcd therefore is more stable if it uses an odd number of nodes. Internally, etcd is implemented as an immutable key value store. Any change to key value pair is stored as a new entry with a new version. In production systems, it is very important to back up etcd. The etcd client tool provides a backup utility that can be used. The third component in the control plane is the controller manager server or kubectl manager. It performs lifecycle functions such as namespace creation or garbage collection. It also performs certain business logic such as scaling of pods. It is run as a daemon and is responsible for regulating the state of the system. The controller manager is a single binary that includes multiple controllers, such as the node controller, which manages various aspects of the nodes, such as responding when the nodes go down, replication controller, which maintains the number of pods as specified in the replication controller object, endpoints controller creates the endpoint object that joins services to pods, service account and token controllers that creates the default account. The controller watches some object for the system's desired state, and it watches the system's actual state too. It then sends instructions to try and make the system's current state to be more like the desired state. The last component of the control plane is the scheduler. It is responsible for figuring out which node a particular pod should run on. It looks for pods that haven't been scheduled and nodes that have capacity to host that pods. It considers various factors such as hardware or software constraints or data locality to when assigning nodes to pods. It then tells those nodes to run the pods. Although the default Kubernetes installation provides a scheduler, it is possible to use a user-provided scheduler. Next, let's look at the components present in the nodes. Each node contains kubelet, container runtime, and the kubeproxy. A kubelet is responsible for running the containers that a user specifies. The fundamental unit of execution is called a pod. A pod contains one or more containers and volumes. The kubelet runs a pod based on specification provided by the user. This specification is known as pod spec. The containers that the kubelet runs are isolated from each other and also from the host. It is the kubelet that ultimately decides what pod can or cannot run on a given node and not the scheduler. The next component is the container runtime. The nodes run a container runtime that is responsible for downloading images and running containers. This container runtime implements a container runtime interface or CRI that specifies requirements for a container runtime to integrate with kubelet. The most widely known container runtime is Docker. However, the container runtime interface supports interchangeable container runtimes. Internally, the kubelet communicates with the container runtime over Unix sockets using the gRPC framework, where the kubelet is the client and the CRI is a server. In CRI, the pod environment is called pod sandbox. Before starting a pod, the kubelet creates the pod sandbox and sets up networking. The kubelet is responsible for maintaining the lifecycle of the containers through RPC. The final component in the node is the kubeproxy. The kubeproxy allows to balance load between the various pods in the node. The main task of kubeproxy is to program the IP tables so that it captures the traffic to the services cluster IP and port and forwards the request to one of the services pods. We have covered a lot of material in this video. We'll go through some of the components in detail in the later videos. As we progress through the course, you will get more familiar with the various components. It would be worth coming back to this video after a while just to get reoriented. The next short video introduces what Kubernetes objects are. See you in the next video.